Okay, thank you for coming to the second half of our mobility single sign-on track. So we covered a bunch of stuff this morning. So I'm John Bradley from Ping, for those of you that don't know me. So I'm the person who Patrick was whinging about not having the NAP specs done this morning. And, well, lots of people whinge about me not getting lots of other stuff done. So my wife does not have a monopoly on that. So let's have a look at where we're at with single sign-on for mobile devices. I'm going to take a quick look at the current model for OAuth for native apps. Then dig into some of the building blocks. Pixie, which Eve Mailer actually came up with the name for our acronym, which is cute and I don't know, Pixie-ish. I didn't even know that it was a candy until Brian pointed that out this morning. Authorization for cross-domain code, ACDC, which you'll notice that we do actually have a fashion statement happening with that. It took us a while to re-acronymize a name that came out to something cool. So that was about 5 Google engineers and 10 other high-level people from different companies who sat around for an entire afternoon to come up with that for your enjoyment. And we have some information about native account chooser, which Google is now calling Smart Lock. Microsoft is building something similar, etc. So let's have a look at the current pattern. The default that most people are seeing when they use OAuth on native devices. Each application, retrieves tokens on its own to get to make API calls, employees, individuals, etc. American Airlines, as an example, flight attendants, I think, have 10 or 12 different apps that American Airlines uses that they have to do for different things. So when I fly, I quite often have them because living in South America, I know a large number of the flight crews that I have to interact with quite often. So they actually they come to me and we're whinging that having to log in 20 or 30 times a day was really annoying, and it was likely my fault. So it does get silly as people have short timeouts and lots of different applications that aren't shared. And right at the moment, because people are using embedded web views, which is at least on iOS, is what Apple is attempting to drive people to. The session state in the browser isn't actually shared between applications, which again drives, even if you're doing SSO from the different SaaSes, the user still has to wind up authenticating multiple times, perhaps multiple times with multi-factor authentication to make each app happy. So let's have a quick look at the actors and how this happens. You have a phone with a native app, an authorization server with some endpoints, and a resource server. So in the Connect flow, the native app pops a web view, which the OAuth spec says you really should not do, because there's if an app collects your credentials or an app gives you a web view for you to enter your credentials into a remote website, there's nothing that stops them from scraping your password and all of that. So, it may be not a concern for you because it's your native app as an enterprise, but once you teach users that that's okay, when they install some other app that brings up a screen that kind of looks like your enterprise sign-on, they may well be more than happy to provide an inappropriate party with that information. But currently, most people, that's a user agent, a web view inside the native app, makes a request to the authorization endpoint, authentication happens, single factor, multi-factor, what have you. The native app gets back a code in the code flow, which is what most people use for native applications. I know some people have asked me about whether or not they should be using implicit flow, but we really, when we were designing the OAuth specs, we actually intended for native applications on devices to be using the code flow. I know that the implicit flow says for things that can't keep secrets, and of course native apps, unless you do dynamic provisioning, can't keep secrets, but you should still be using the code flow. So there's perhaps a little bit of ambiguity in the specs, but let's assume it's using code flow. It then sends the code to a token endpoint and sends back tokens. And the app then uses the tokens to access the resource server, which is closely associated with the authorization server. And the authorization could have called out to SAML SSO or OpenID Connect, what have you. And again, when you have a second app, you jump through all the, you jump through it all again because there's no concept of sharing the sessions between the web views. They all have completely separate state, so the session cookies aren't currently shared. So the implications of that are that the employee bears the burden of authenticating however many hundreds of times a day you wind up making them do it. And you can probably make your employees do a lot of unreasonable things, but in the consumer space, every unreasonable thing that you ask someone to do loses you conversions or customers or whatever opportunity you're attempting to do. So certainly outside of the enterprise, the user experience is pretty important, and not pissing off your employees isn't a bad thing either. The other issue is that in that flow, even though you may be doing password sync, dir sync between the SaaS and yourself, or maybe calling back for SSO, but you really the enterprise loses the thread. You have a disconnect between your web authentication and the actual OAuth stuff that's happening after that. So there isn't an easy way for an enterprise to revoke those OAuth tokens, because it doesn't even know that OAuth happened or what scopes. It's completely out of the loop there, other than doing the authentication for the, say, a SaaS or enterprise authorization server. So you can kind of get around this for a single enterprise, but once you start using SaaSes, you wind up having more problems. So let's take a look at the NAPS ACDC flow for an enterprise, assuming we have an enterprise AS. This is where it gets a bit different. So the native app on the device makes a call to a token agent, which it can discover on the device. So it sends the request plus something called the code verifier, which actually comes from Pixie. So there's some modularity to these specs. So Pixie, which protects the code, is sort of an independent spec. You can use that on its own, and lots of people do. ACDC sort of builds another layer on top of that, and NAPS provides sort of the overall wrapper for it. So people may well end up using different components of this. So the app makes the request. The token agent, if the user isn't authenticated, will make a request, do something to authenticate the user. Now, the nice thing about the token agent is that on most devices, it can check the bundle ID, the signature of the app that's calling it, which is something that you can't do remotely. If you have that native app just calling back to the authentication server itself. So if you have a trusted token agent, which you in principle, through having some sort of MDM, you can have, provision a credential to it, perhaps a certificate, do TLS client auth for the device. You can do multi-factor authentication, have that token agent check to make sure that there's a screen lock, check to make sure that the device hasn't been rooted, any number of other things. So it's a good point of control. and could even have a FIDO authenticator baked into it. I know some people have been considering how to do that.
Ships in Win 10.
The FIDO authenticator in your token agent? Excellent. If it were only a standards-based token agent, but we won't talk about that right now.
We'll talk about that once the standards finalized.
Yeah. The more I hear about what you've done in Windows 10, the more encouraged I am, but it has been a challenge for some of us to actually extract some of that information. But what's in Windows 10 is actually not all that far from what we imagine NAPS is going to be and what Google has done in Android and other stuff. So we're on the same path. Hopefully we can join them up at some point. So the token agent gets back a code. It then uses the code to get a refresh token. And as we progress with the token binding specs, which Patrick mentioned this morning, and I'm working with Microsoft and Google on at the ITF. I'm the chair of the token binding work group. We intend to have on Android that refresh token for the account manager. Currently uses the current version of token binding to actually cryptographically bind that refresh token strongly to the token agent and that device. So that's actually, at least on Android at the moment, not a bearer token for those people concerned about security. And I'm probably the obsessive proof of possession person in the room, having worked for evil people in the past. So we get the refresh token. The refresh token is then used on another call because we had a native app that wanted client. It makes a call. There's a couple of extra parameters. There's an audience which lets the token agent say to the AS who you want this ACDC token for. So one of the things that Google and some of the initial implementations, AZA from Ping, et cetera, we were overloading scopes with a bunch of things that were confusing and sort of polluting the namespace. So we've taken some of those things and actually made them distinct parameters to make it a bit easier for developers, rather than having structured scopes, which is kind of craziness. So based on what audience you want, you get back the tokens. And in the request from with this refresh token, the code challenge, the Pixie code challenge from the first step down there was actually passed to the token endpoint, so that the ACDC token that comes back actually has a confirmation element which has the code challenge in it. So in Pixie, there's essentially a SHA-256 cryptographic transform, so that even if you get the code challenge, unless you have all the time in the universe, actually brute forcing that to figure out what the code verifier isn't practical. So it's a bit like a one-time password hash, So it's as simple cryptography as we could come up with, so that we could get developers to do it, but it actually is pretty strong. Oops, go forward. So the native app gets the ACDC token back. It then uses the ACDC and the code verifier, which went with the code challenge, to talk to the token endpoint. So if another app had intercepted that reply, or even the request, it wouldn't be able to do anything with it, because only that app has the code verifier. And the token endpoint then returns refresh tokens and access tokens. So one of the reasons why we decided to have the app manage its own refresh tokens in the default case is that on some mobile operating systems, which shall not be named by Apple, they really, really get angry with developers when they do app flips. So making a call between applications is both insecure and annoying. We decided that it was best to have a default pattern where the native app would have its own refresh token, which can then be revoked out of band, rather than in what we had imagined in some of the early versions was using the assertion, the JWT assertion flow. But that meant calling back to the token agent to get new tokens, etc. Really had problems, at least on iOS. So that's why we've gone with giving the app its own refresh token. It then uses the token to access the resource server. So let's look at how this works slightly differently when we have a SaaS added to the picture. So a SaaS app would do discovery back at its, we have some other presentations on identifier first, etc. So assuming the app collects the information about the user, it can either use a local account chooser to get that or prompt the user. It can then call back to, if it isn't part of an MDM or managed by an MDM, it can then call back to its SaaS service and figure out what the configuration is for that particular enterprise. It then, based on the enterprise that it's using, would know what token agent it needs to talk to, because there may be multiple token agents on the device. So it will configure itself for the appropriate enterprise, and then make a call to the enterprise token agent, again with the same pattern of requesting an ACDC, sending a code challenge, makes the call to the token endpoint, gets back an ACDC token, which again has the code challenge as part of the confirmation element. It then gets back the ACDC token, which the SaaS app then makes a call to the SaaS's token endpoint and essentially does a token exchange, proof of possession token exchange. So it sends its ACDC assertion. So the ACDC token is a JWT assertion. Makes that assertion so additional attributes about the user can be passed that can be encrypted, etc., as appropriate. Goes to the SaaS. The SaaS verifies that it was presented by the right application. The enterprise has validated, knows exactly what the binary of that native app is, so it can throw out apps that people ought not to be using, etc. So the enterprise has done, in the first instance, the user hasn't needed to authenticate again because the token agent was in the first step strongly authenticated to the enterprise AS. So based on that, it was able to continue to get access tokens for the SaaS app. That assertion goes to the SaaS along with whatever attributes are required in the ACDC token. It then gets back refresh and access tokens and uses the token to access the SaaS. Okay, and something has, I think the fonts are a slightly different size on this computer. Anyways, there's a spec which, again, people are whinging that I haven't finished yet around token revocation. So cleaning up sessions. We're working on a back channel method of sending JSON web token to be able to revoke sessions from the enterprise to the SaaS. So in the first step, when the ACDC was generated, there's a session identifier that's actually put in that token so that you can revoke individual sessions for an individual device. And we're imagining that there will be, perhaps session isn't the right word for it, but something equivalent to sessions for OAuth, which identify the activities that a person is doing on a device so that you can, from the enterprise, say, John has lost his Nexus 6, kill off all the access tokens at all of the SaaS apps that he's using for that device. So when that revocation token would go to the SaaS token endpoint or special endpoint at the SaaS, and the SaaS would have to use whatever internal mechanism it would use for revoking the access token. That may be revoking the refresh token so that in some given time period when it goes back to ask for an access token, that would get rejected. It all depends on the design of the SaaS, how real time they want to make it. Then when the next time the SaaS app on the device attempts to use the token, it would get a error reauth, a new type of error message, which would tell it to clean up its cache data and go back and do whatever it needs to get new tokens. So that could be the result of the employee being terminated or some other policy by the enterprise. You want to, see the user again before they actually get access to that app. So it could even have been that there had been some other access by some other app that caused the token agent to tell the enterprise AS, oh, look, this device is now, even though it's perfectly reauth, you've now moved to Tajikistan based on your IP address. Maybe we're going to turn off the corporate financial transaction app or some such. So it gives the potential of a lot more control for the enterprise. So the advantages are that it reduces the number of times that the employee has to actively authenticate, because the token agent can actually participate in other sorts of passive authentication on the device. It could be checking on person, it could be checking facial biometrics, or making sure that the device is pin locked or fingerprint locked, what have you. So there's a lot of things that you can do that would allow you to very strongly make sure that it's still the same person that's using the device without being as inconvenient as asking them for their password, which is most likely going to be auto form filled by LastPass that they've installed. So reprompting them for their password may not actually be doing what you want in many circumstances. So we have to improve that so people actually get the results that they're expecting. And the user can do SSO across all of those applications. They can also, Adam Lewis was talking this morning about, we also have a proposal for being able to create tokens, which would then allow you to do web SSO, create sessions in the system browser.
Would the user still have to consent to the new applications?
Yes. So, but they would be consenting to the new applications at their enterprise as opposed to at the SaaS, which has. So the enterprise AS that the token agent is talking to has the ability to basically have better control of the applications that they're giving tokens to, as opposed to, oh, you're this SaaS, I'm going to you're going to have your own AS and whatever apps they decide, the SaaS decides can access. So it gives more control to the enterprise. So we have, one of the components is Pixie. So it's currently in IESG review, which is one of the 7 rings of hell for me. So if you see me staring at my phone, it means that some senior person in the IETF is picking on me, wanting some nitpicky change in the spec. So this is the final stage of becoming an RFC, which is no fun when you're an author, but great sport for me when I'm on the other side reviewing other people's specs. So this is perhaps some revenge. So I expect that that's actually going to be done pretty quickly by IETF standards. Hannes, in the back of the room, come on, wake up. So how would you, since Hannes is the chair of the OAuth work group, if you have any complaints, take them to Hannes, who's sitting in the back. If any of your ARM devices aren't working, he's also a good person to talk to. He can arrange free replacements. So Pixie, what's your estimation for completion? It's actually going quite quickly by IETF standards. Few weeks maximum. Excellent, I'll hold you to that. You better back me. So it's going. It'll be done pretty soon for those people who want it to be a standard. But it's already well deployed by Deutsche Telekom, Google, Ping. I think Ping has had it in product for almost a year now. So it protects against the malicious interception of the code, both on the wire and on the device. So there was an attack that Google discovered against themselves, which is one of the reasons why they have this in production, is people on iOS were, I don't know, this is probably, is it, okay, just make choking noises if this was a secret.
Well, that's Eric.
Okay, so, okay, Eric Sachs may be killing me later, but people were putting apps, you know, the I'm a cute fuzzy kitten fart button apps or whatever people were downloading to get somebody to download. And what the app was doing was actually registering the same URI or custom scheme as the YouTube app, which is one of the core Google apps that actually acts as a token agent on iOS. So they were essentially trying to act as a man in the middle so that when or actually it was the callback. They weren't registering as YouTube. They were registering as other like bank apps or other applications that were using the Google token agent and intercepting the response. So they were getting the access tokens that Google was handing out supposedly for the real app. So they were basically impersonating apps because the custom scheme URI callbacks on iOS, it used to be at least deterministic. It used to be the most recent app that you had used, iOS would call back, but now for some reason they decided to go to some sort of round robin polling thing. I've never entirely understood all of their use cases for sort of having this, allowing people to overload the custom schemes and having round robin, but when you're using it for security, that's not actually a good thing. So Pixie basically stops those attacks of people trying to install apps that perhaps would steal banking credentials or other things for people that are trying to do similar kinds of token agents. We have two levels of security. One, which is a plain transform, which is essentially, because it's the callback to the app that normally gets intercepted, you don't really need to protect the request. In ACDC, we require you to use the SHA-256 transform, which protects both the request and the response. So the ACDC, which is an OpenID Foundation specification. So it supports both native token agents and in the browser. So you can use the ACDC flow for essentially doing federated OAuth, even with a straight browser. So you could, rather than having a token agent, or if you have an app that uses a token agent, if the core app isn't installed, it can still actually do the same flow through the browser by sharing, giving you SSO by keeping the session cookies in the browser, but it will still work the same way for the SaaS apps. Requires Pixie, and it can be used by both enterprise and social providers. We also have native account chooser, which Windows 10 has kind of a version of that, from what I understand. Last week, I guess it was last week at Google I/O, Smart Lock, which is native account chooser, but most people think of as a password manager because that's mostly what people talk about. But it actually has the ability to express, you can do a search for what federated accounts does the person have provisioned on that device. So we have a hosted version of Account Chooser that the OpenID Foundation runs for web browsers. So we expect to see more native devices and or browsers actually incorporate that user preference functionality actually into them rather than relying on the hosted JavaScript version. But Smart Lock on Android at least, you can do a query on what social providers does the person have, and it would come back with an ID hint and a OpenID issuer URI, etc., so that you could do federated identity for those. So let's look at how this might work outside of the enterprise in the social case. So somebody, I don't know, LinkedIn could have a token agent that was provisioned on the phone. You have an app that wants to knows how to use social identities. So this could be TripIt as an example. So the app could discover that you have, through Smart Lock, discover that you have a LinkedIn token agent. It would then, it knows how to log people in using LinkedIn accounts. It would make a call to the LinkedIn token agent. So this could be, any social provider. Google does this now on iOS with the functionalities built into YouTube and a couple of the other Google apps, which apps can call to get tokens from Google. The social provider uses its refresh token to call its token endpoint, get an ACDC token, goes back, and then would make a call to its token endpoint with the code verifier to get access tokens. Now, at the moment, I think most of the people that are using the pre-NAPS Google version of this actually get back an ID token, which they just cram down straight as the access token to their enterprise API in a slightly less sophisticated version of this. But in principle, you should be actually doing a token exchange on either the ID token that you're getting from Google or the ACDC token, which is a differently named ID token. So that you actually do get proper access tokens and can maintain security on the third-party authorization service. So NAPS isn't just for enterprise. We think that as we get token agents onto devices in a standardized way, that most apps should start using those native functionality and the account chooser on the device to be able to provision the identities into the apps, and essentially be able to take advantage of all of those features. And they do get their own access and refresh tokens. The user can go back to using the same mechanisms that we had for the enterprise. If you went back to LinkedIn, you should be able to be presented with a page of all the different OAuth sessions that you have, and they do keep track of OAuth tokens at the moment, but they should be able to keep track of the ACDC tokens and allow you to send a token revocation, which would then essentially clear any application that you had that was talking to that SaaS server, which is overall better user control and hopefully more understandable to people. So the same reauth error. So those are the sort of underlying specs for that go with NAPS. So I've managed to go over myself. Excellent. I'm a horrible speaker. So I know that Andy has about 1 billion slides. So while he comes up here and figures out how to do that, are there any questions?
Token agent, do you mention it being a standalone app, or will it be part of the mothership app, say for LinkedIn?
Well, it will sort of depend on the operating system. Andy's going to talk about some of the things that might wind up looking slightly different on Android versus iOS. So for the enterprise, it will likely be a standalone app or a standalone module in Account Manager, etc. For social, it will probably so Facebook was using a custom API that Apple had built for them until Apple didn't actually maintain it and make the changes that Facebook wanted. So they've actually abandoned their custom iOS integration and gone back to a more NAPS-like approach with the Facebook app, acting as the token agent essentially for other apps calling it. So it will sort of depend upon the use case, but it could be either way. Or you?
All set?
Yeah, I was just killing time while you were getting your presentation going.
Which product does the token agent fall under?
Right now we have it's part of Native Cloud Desktop. I think we still call it AZA or AZA if you're an American, I suppose. I can
Good to
speak
go.
now.
Let's give a round of applause, though. That was excellent.
Okay.